In this lecture, we're going to talk about division of polynomials. So the best way to show you how to do this is specifically with some examples. Now, let's say that we have this trinomial and we want to divide by this binomial. Now, unless the factorization of the numerator is clear, the reduction is going to require some kind of long division. Okay, so what you're going to get in the end is a polynomial and then another rational. All right, and the this is the procedure. So we're going to write the numerator, x squared plus 4x minus 8, right? And you want to make sure that this is sort of in descending order of powers of x whenever you do in this process. And we're going to long divide by x minus 3. Okay, now the process is very similar to long division of numbers that you're sort of used to. Now, the first step is let's just cover this -3 here. And then looking at this leading term here, x, what do we have to multiply x by to get the leading term here? Well, the leading term under the division is an x squared, so we would have to multiply x by x to get an x squared. So that's what you write. Okay, so we're going to write x up here, and then what we're going to do is we're going to multiply this x by the entire, well, it's originally the denominator, but what you're dividing by. So you sort of cover up everything but the leading term to determine what goes up here. Okay, but then once you have determined that, then you take this and multiply by this whole what you're dividing by. So what is x times this? And we're going to write that under here. So x times this expression is x squared minus 3x. Okay, and just like long division, this is what we are going to subtract and simplify. So x squared minus x squared, those are going to cancel. That'll give us 0x squared, but then 4x minus 3x, so that'll be a plus 3x, so this will give us a 7x. Okay, and just like long division, you can kind of like bring the next successive term down, and then we sort of start all over. So now looking at this, the 7x minus 8, okay, and starting the whole process all over again, so you cover up everything that you're dividing by except for the leading term. What do we need to multiply x by? What do we need to multiply this x to get 7x? Well, we would have to multiply this by 7. So we're going to put that there, plus 7. Okay? And then now you take the 7, and we're going to multiply by this whole, what you're dividing by. So we would get 7 times x is 7x, and then 7 times minus 3 is minus 21. And now this is what you're going to subtract. Okay, so the 7x and the 7x are going to cancel. The reason for that is because we chose this number so that the cancellation will happen. And then now we have -8 minus 21. So that'll be a plus 21. So what would that be? That would be 13, right? So, okay, so now we have our answer. So all this work, what does this tell us? Okay, so that tells us that this whole fraction is equal to your answer, and then this is sort of your remainder. Okay, so your remainder is 13 divided by what you're dividing by, x minus 3. And that is the process of long division. Okay, so let's do another example. We have this trinomial, and we're going to divide by this, okay? And let's assume, no factorization worked out, right? Or you just have to do this by long division, you're told to. Now, if you look up here, this answer, the fact that we actually have a remainder, tells you that x minus 3 is actually not a factor of the numerator, okay? Because if it was a factor, then you would just get something, you would get a 0 remainder, okay? But we didn't. So that's something you can tell by getting a non-trivial remainder. So to set this up, right, you're going to do 2x minus 7, and we're going to divide the 8x squared minus 26 minus 9. Okay, so we cover up everything that we're dividing by except for the leading term of this 2x. And what do we need to multiply 2x by to get 8x squared? Well, we would need to multiply 2 by 4. Oops, this should have an x here. Okay, and we would need to multiply the x by x, so 4x. Okay, so just double check yourself. 4x times 2x is 8x squared. So that's the correct beginning of the answer. Okay, now we take the 4x and we multiply the entire denominator. So we will get 8x squared, and then 4x minus times minus 7 will be minus 28x. And we are going to subtract this whole term. So we put that in parentheses. These should cancel. If they did not cancel, that's bad. That means you had some leftover portion that you. So this is not this would not be correct, but this is correct because they do cancel. And then we have minus 26. Minus minus will be plus 28. So this will give us positive 2x. And then we bring the lower ordered terms down, and then we start the process all over again. So start by covering up everything but the leading term. What do we need to multiply 2x by to get the 2x here? Well, they're the same, so I just have to multiply by 1. And now 1 times the entire denominator is 2x minus 7. And then we're going to subtract this. And we have minus, so this will give us 0, but then minus 9 minus minus is plus 7, so that'll be negative 2. Okay, so all this work here, what's up here is the answer, the 4x plus 1, and then we have to add the remainder. The remainder is minus 2 divided by the denominator, 2x minus 7. You know, you can always actually check your answer if you wanted to, because you could make a common denominator for these two, right? We'd have to multiply these two by 2x minus 7, and then you could simplify and see if you actually get the correct answer in the end. For our last example, let's divide this cubic by this linear polynomial here. So 3y minus 3 divided by... Okay, now notice that the terms are in descending order, right? So 9y cubed minus 6y squared. But you know what? I'm going to leave a little bit of space because you notice that there's the y term has a coefficient of 0. So I'm just going to leave some space there. And the reason for that is because when we start to do this division, we are going to be determining what we need to multiply this 3y by to get each of the successive results, right? But at some point, it's likely we're going to have to multiply by something times y. And so I'd like to write that above the y term space. But since there isn't one here, you know, it'll just make it much more organized. If there's ever any missing terms, if you leave like a space there for it when you're doing long division, it'll make it much more organized. You don't have to, but it's just a little bit easier to follow. Okay, now covering up everything except for the leading term of 3y, what do we need to multiply 3y by to get this leading term, 9y cubed? Well, we'd need to multiply it by 3y squared. So I'll write that above the y squared term. So now 3y squared times the entire thing, we'll get 9y cubed. And then 3y squared times minus 3 is minus 9y squared. And now we're going to subtract this whole term. So we'll get 0 from the cubes, right? They'll cancel. But then minus 6, minus minus will be plus. So plus 9 will be positive 3y squared. And we could bring down this positive 8, but the only thing that's going to matter is the leading term, really, in determining what we need to multiply by. But now look at this. So what do I need to multiply the leading term, 3y, by to get 3y squared? Well, I need to multiply by a y. So now you can see why I'm putting this extra space here. So all the y terms are sort of in a column, all the y squared terms, all the y cubed, and all the constants we'll see in the end. So now y times this whole thing will be 3y squared, and then minus 3y. And we'll subtract this. So you see now there's no need to bring this 8 down because it's just going to end up being down here anyway when we bring it down for the next calculation. It would just get carried along. There's no need for it. There's nothing wrong with doing it, but look what happens. So these cancel, and then we have, this is actually a 0y, right? So minus minus will make that a plus 3y. And now we bring down the 8, and we'll actually get a constant term, hopefully, to actually subtract. So what do we have now? What do I need to multiply the leading term of 3y by to get this new leading term, 3y? Well, 1. And 1 times 3y is 3y. 1 times minus 3 is minus 3. And we will subtract 0, but then plus 3, 8 plus 3 will be 11, right? Okay, so all of this work tells us that this fraction, this rational expression, is this polynomial 3y squared plus y plus 1, and then plus the remainder of 11 divided by what we're dividing by, the 3y minus 3. Okay, so when you do this long division process, you're always going to get a polynomial as the answer. You always get a polynomial, and then you'll get a remainder term. The remainder could possibly be 0, but whatever remainder we get in the end, the degree of the remainder will have to be less than the degree of what you're dividing by. And since I'm dividing by a degree 1y, a linear factor, I know that that remainder would have to be a constant. Like if you were dividing by a squared term, then the remainder could actually be constant or a linear. Okay, and it's just something that takes practice, and after you do enough of these, you'll get used to this pattern.